Okay, so approaching the problem, we'll be talking about the function y is equal to f of x, the 5 y's, and creating a problem statement. Okay, these are the three things that we are going to see today. So the problem functions, y represents the outcome. Okay, y represents the outcome, result, okay, or the effect. Okay, you can type in the chat box outcome, result, okay, effect or output, whatever it is. Okay, you can, these are all synonymous words and we use in different phases of Six Sigma. It can be output. Please write it in your notebook. Y means it can be output or outcome. Y means it can be the effect. Okay, Y means it can be the results or a goal. Okay, these are all equivalent. Similarly, for X, the equivalent words are inputs. It can be inputs, it can be the causes, it can be the factors. Okay, inputs, causes, factors, all that. Okay, and function means, that means that this one is dependent on this. Okay, the output is dependent. Function means it is dependent. Function by which we mean that it is dependent on the causes. Okay, if so far if it is clear, type SC, super clear, in the chat box. Good, thank you very much. All right, so y is equal to f of x. Suppose if you want to successfully start a Six Sigma project, it is crucial to identify and define the problem very, very clearly. Okay, so we call this as independent variable. Independent variable means it's a cause. Okay, it is a cause, and this is a function, and this is a dependent variable because the output is dependent on inputs. The effect is dependent on causes. Okay, the outcome is dependent on factors. Okay, factors, various factors. So in this chapter, particularly the sixth chapter, we focus on creating a general problem statement by asking why questions. Okay, why questions. That is why I have actually merged y is equal to f of x with 5 y's. Okay, which is the foundation of any project. Then we will discuss defining various aspects of the project, various aspects of the process, and various aspects of the problem in more detail. Okay, because Six Sigma approaches things with a statistical mindset. Okay, all of you type statistical mindset in the chat box. It's very, very important. You need to create the statistical mindset, which means that data-driven decision making. Data-driven decision. Take decisions based on data. In God we trust. We can trust God, but rest of them should bring data. If you like it, give me a thumbs. In God we trust, but rest of them bring data. So the general way to describe the problem. Thank you very much. I hope you like that statement, right? Because make sure you make decisions based on data, but don't ask God for data, okay? Okay, so why, the capital Y, the problem, okay, happens because of several causes. Every problem has a cause. How many of you agree? Type agree in the chat box. If I'm down with fever, there is a cause. If I'm down with cold, there is a cause. If I'm not getting promotion, there is a cause. If I'm late to office, there is a cause. If you are not learning a best problem solving methodology, there is a cause. Okay, many people are asking, you want to access recording, you want to access presentations. Don't worry about that. I will share in this upcoming webinar. I'm going to share the complete Lean Six Sigma training manual towards the end of this session. I will also tell you how to access the presentations, how to access videos. Don't worry about that. And I'll also tell you how to get internationally recognized certification. Let's focus on the subject here. In reality, it is not just a single cause. There will be multiple causes. If you agree, type MC in the chat box. There is no single cause. Generally, there is no single cause. There are multiple causes. Okay. And when there are multiple causes, one cause will have more impact than the other cause. How many of you agree? When there are multiple causes, one cause will have more impact than other causes. Suppose if I am not energetic today in my presentation, there will be a cause. The effect is, hey, Dr. Murli, I don't see you energetic. Okay. There might be multiple causes. There might be multiple causes, but there might be one dominant cause. Okay. Or there might be few causes which is creating more impact and other causes creating less. So the communication I want to make is that there will not be one cause, there will be multiple causes. So as you look closer this equation, y is equal to f of x, the concept becomes a little mathematical. Though I've written more mathematical, I don't want to scare you. But it might look mathematical, but if you graph it, if you put it in the form of graph, I'm going to teach you several graphs. I'm going to teach you Pareto graphs. I'm going to teach you histograms. I'm going to teach you box plots. I'm going to teach you dot plots. I'm going to teach you individual value plots. Okay. I'm going to teach you multivariate plots. But how many of you are excited to learn all this? Type ETL in the chat box. Once you see it graphically, then it becomes so interesting and useful. It becomes so interesting and useful. So it is not about mathematical formula. You will have, I'll teach you all the graphical analysis. Please register for this upcoming session and come to a part of Inner Circle. We share a lot of case studies. We share a lot of software analysis. Okay, to help you understand this, I will take an example of a HVAC system. What is HVAC? Anybody knows what is HVAC? Let's see if somebody knows what is HVAC in the chat box. What does H stand for? V stands for? Any idea? Yeah, correct. Some people already started. Heating, ventilation, and air conditioning. Okay, great. Good. There are a lot of, I didn't know when I saw first HVAC. I didn't. I mean, I heard about this term, but I was not able to expand this. Okay. Then I thought, like me, somebody may not know. So I started putting this acronym here. So to understand this concept of thinking of problems as functions, let's look at this problem that might occur for a large HVAC service provider, because in the air condition you do service, right? So if you are a manager, of a team, service team, you have discovered that the service calls are taking much longer than expected, because people call to service their air conditioning, right? The calls are taking much longer than expected. He has got a 5-member team. It is taking 1.75 times more than the average reps in the company to handle these type of calls. So the effect is, the problem is, problem, effect, outcome is that the service calls are taking longer time. That's a problem. There must be a cause. There must be a cause. Why do you think the service calls are taking longer time? I'll just open up the chat box for 30 seconds for you to type your thought on that. If you are the service manager, why do you think that calls are taking longer time? Lack of training, very good. Intake questions, language barrier, fantastic. Lack of experience, superb. Lack of accountability, wow. Lack of system, lack of information, too much chatting, very good. Actually, this is a problem that he discovered, too much chatting. Okay, fine. We are not asking the right questions. Absolutely, absolutely. Okay. So whatever answers that you gave was right. And let me reveal to you what exactly the service manager found. Okay. The manager researches the problem by talking to the representatives, talking to the customers, and going out on random calls with all the 5 representatives. And he makes the following observation. Like you rightly said, one representative is native to the area. Okay. He is a native of localite. Okay. Local person. So he started entering into some friendly chatter. Somebody put chatter in the chat box. Okay. I was surprised that he started entering into friendly chattering, okay, talking with lengthens the time on the job. The other person gives too much explanation in education about it. Whatever he knows about HVAC, he started giving too much explanation instead of coming down to the point and addressing the questions. Okay. And the third one was probably a couple of them where third representative was new to the job. Okay, so he's always careful. He's always double checking his work, calling with other representative to check whether what he's doing is right or wrong. Okay, and the remaining two representative perform work in times that are par with company averages. Okay, now if this so far is clear, type SC, super clear in the chat box. Okay, somebody said the presentation is not visible. I hope all of you can see the presentation. Say yes in the chat box. Okay, now if you see here, the manager distills down this data to two overall causes of the problem, which is too much talking and inadequate training. So the problem function can be now be stated as a function. The extra time is a function of too much talking and inappropriate training. Okay, the manager also now has two root causes to address. This example is very simple. Okay, it illustrates the concept of y is equal to f of x for the problem or outcome or the effect, okay, with causes or inputs or whatever it is. Okay, so far if it is clear, type SC super clear in the chat box. All right, thank you very much. So it is not always easy to conduct the research and analysis to find out the relationship, but the relationship is always present whether you take an attempt to find it out or not find it out, the relationship always exists. Okay. Okay, some other examples. Okay, what do you see on the screen? Okay, 1 second. So problem is a function, y is equal to f of x. Okay, y is outcome, result, goal, x is input factors, f. Okay, then y is equal to f of x. Define the problem clearly. And these are the dependent variable, independent variable, and creating the general problem statements. Okay, and all that. So Six Sigma approaches, that's why this is where I asked you to type statistical mindset, y is equal to f of x. Okay, and then you have two ways, the problem and the causes. In reality, y usually happens because of several causes or inputs. I was reading this only. Okay, as you look closer, y is equal to f of x concept becomes more mathematical, and you can often graph the relationship. That's when I said you can always do a graphical representation. Okay, then we went into HAVC system, which is heating, ventilation, air condition. And then there was a service call issues. The service calls were taking 1.75 times longer than expected. And hence he decided to research with 5 of his representative. And somebody was taking a long time because he was a native. He was entering into chatting and all that. And other person started giving in-depth explanations. And the third one was new to the job, so he is double checking. Now, so too much talking, inadequate training, and hence the extra time is a function of too much talking and inappropriate training, and y is equal to f of x. Okay, so if this is okay, if this is clear, please give me a 9 or 10 if it is super clear now. Thank you very much. All right. Even if you're not able to find out, even if you're not able to research out, the relationship always exists. That's what we concluded. Okay. So now what do you see on the screen? Let's come back. Okay. Now what do you see on the screen? Hamburger. Okay. So low customer satisfaction with hamburger taste is a function of uncalibrated grill. How many of you understand? How many of you agree? Yeah, y is equal to f of x. And what do you see on the right side? I've put some image. What do you see on the right side? I'm sure you would have done this when you could not see the presentation, right? Okay, low employee morale is a function of poor off-time approval system, right? And customer wait times are the function of technology distractions of employees. All right, now the question and answers, okay? How many of you are ready for question answer? Type ready in the chat box. A quick question. All right. In the context of Six Sigma, what does y is equal to f of x represent? Okay. The relationship between output and process efficiency, the relationship between output and multiple input variables, the cost function of production process, the time required for production. The correct answer is the relationship between output and input variables. Okay, please make a note of it. Okay, the second question is, which component of the equation y is equal to f of x represents the output or results of the process? Y or f or x or both y and x? Okay, the correct answer is y. Okay, thank you very much for your participation. Okay, question. In the Six Sigma methodology, what does x typically represent in y is equal to f of x? The final product, the input variables or factors that influence the output, the overall process performance, the defect rate. All right. Great. Fantastic. Thank you very much.